In this lecture, we'll be discussing about the Kruskal's algorithm. So Kruskal's algorithm is a very significant algorithm for constructing a minimum spanning tree. So this Kruskal's algorithm, it builds the spanning tree by adding edges one by one into a growing spanning tree. It follows greedy approach, as in each iteration it finds an edge which has least weight and adds it to the growing spanning tree. So when we will prefer Kruskal's algorithm is when the graph is sparse, when there are less number of edges in the graph, and when usually the edges are already sorted or it can be sorted in linear time. So there are several real-time applications considering Kruskal's algorithm: landing cables, TV network, Tor operations, LAN networks, a network of pipes for drinking water or natural gas, an electric grid, single link cluster. So these are some real-time applications where Kruskal's algorithm plays a vital role. So first let me discuss what is the Kruskal's algorithm. So first what we will do is we'll sort all the edges in non-decreasing order, which is ascending order of their weight. Then we pick the smallest edge. Okay, so that is my starting spanning tree. Next I'll pick the next smallest edge and so on. If it forms a cycle, then I will ignore that edge. Until I connect all the vertices, I'll keep adding edges to my spanning tree. So take an example. So this is a graph. So if you see, 5 is the minimum cost edge and I have two 5s. So in this spanning tree, graph is not always connected. Okay, so first this line, then this line. So I have two lines or two edges in my graph now. Next I'll see which is the next low cost edge. So let me check. I believe 6 is the low cost edge, so I will add that to my minimum spanning tree. Next, the minimum cost edge is 7, so I will take this and this into my minimum spanning tree. Next, the low cost edge is 8. If I pick this 8, then it is going to form a cycle. This forms a cycle. So if an edge forms a cycle, then I will ignore it. Similarly, if I take this 8, this part is going to form a cycle. So I will ignore this. So which is the next minimum cost edge is 9. So this is my next edge which is connecting to G. Now if I see, all the vertices are already connected to my minimum spanning tree. So this is my minimum spanning tree which is constructed using the Kruskal's algorithm. The minimum cost is 39. So let us take another example. So consider this graph. Here if you see, the lowest cost edge is 10. Okay, so include that. Next, my lowest cost edge is 12. So include that in my tree. Next, my lowest cost edge is 14. Next is 16. Next is 18. If I pick this 18 minimum cost edge in my minimum spanning tree, then it will form a cycle. So ignore this 18. Next, the minimum cost edge is 22. So let me include that. Next, the minimum cost edge is 24. If I include this 24, then it is going to form a cycle. So ignore this 24. Next, minimum cost edge is 25. So include this 25 into the minimum spanning tree. Now if you see, all the vertices are connected. 1 is connected, 6, 5, 4, 3, 2, 7. All the vertices are connected to this graph. So this is my minimum spanning tree for the given graph and the minimum cost is 99.